And now in the graph of x minus 3 squared times x plus 1, many people, most people actually, got a graph that looks something like this. The 0 at x equals negative 1, the 0 at x equals plus 3, and the y-intercept, which is 9, 0, 9. So we have 3 points that look like this, and people are getting graphs that went up here, kind of a boring looking graph, and came back down through here. Kind of missed that point. We'll just enlarge it. Okay? And that's a perfectly valid graph. It could well be a parabola, but of course you multiply this out, you find it's got an x cubed in it, and it's not a quadratic, so it's not a parabola. Still, there's no reason the graph couldn't look like this. Well, there is a reason, but there's no immediately obvious reason why it couldn't look like this unless you're clued into what happens here. Okay, well, the problem with this is that the end behavior, the behavior for large x, if x was, say, 10, then this would be 7, this would be 11. This is squared, and it's certainly going to be positive, and this is positive, so that the behavior here has to go this way, and this graph goes this way. So we need to have this not this, which is what we have on this picture. On the left, same story turns out. I'm sorry, not the same story, but on the left, this is going to be positive. Doesn't matter what x is. This is going to be positive unless, excuse me, we're at x equals 3, we're at 0. But if x was negative 10 even, we'd have negative 9 here times a positive here, which would give us negative. This is okay. So it does go down on this side, but it doesn't go down on this side. Now, how are we going to make that happen? We've got 3 points here, here, and here. Again, how are we going to go through those points in order from left to right? Of course, we could try turning this around and coming up, but it can't go through 0 except here and here, because it's very clear that if x is anything but 0, this isn't 0, and this isn't 0, so when we multiply them, it's not going to be 0. So if x is anything but one of the zeros, if x isn't 3 or negative 1, this can't be 0. So there's no other point of the x-axis where this can pass through. So we're stuck. To get from here to here, we got to start below to get, and if we go down below here, we can't get back up. Well, I mentioned that we can have this sort of behavior where we hit a 0 but don't actually pass through it. It turns out that's what happens as a result of a squared factor of this nature. A linear factor, an x and a number, or even a multiple of x and a number, squared. Okay? You know that the graph of x minus 3 quantity squared would be a parabola with its vertex at 0, 3. Not 3, 0. And those of you who tend to reverse these take comfort in the fact that I tend to do that sometimes too, reverse the coordinates. So I've got to be careful. Okay, so there's the point 3, 0, which would be the parabola, which would be the vertex of the parabola quantity x minus 3 squared. The fact that this is multiplied by x plus 1 doesn't change the fact that it still acts in the immediate vicinity of 3, 0, very much like a parabola. It's still going to be 0 at what would be the 0 of the vertex, and it's still going to be the same sign on either side of the 0. That resolves the problem, because now we can come up here through this point, come back down here, and we hit the point 3, 0. That is an x-intercept, but we immediately turn around and go up, as we must if we consider what happens for even x equals 10 on this side. For any value of x larger than 3, we are going to have to be positive, and the bigger the x gets, the bigger this result gets. So this is what the graph looks like in this case. You'll read more about this in your text. You'll see more of this in the examples.